Good morning to all. Today we are going to discuss our unit 3 flood and drugs. So in the topic we are going to discuss about the frequency analysis. How we are going to analyze the frequency in the flood based the things we are going to discuss about now. The course outcome of this topic is we have to analyze the assess the flood and drug risk in terms of hazards and vulnerability and assess the measure for mitigating and managing such risk. So the course outcome of this topic is correlated to the program outcome 2, 3, 6, 7, and the program specific outcome 1. So the flood frequency, average flood, standard deviation, coefficient of variation, coefficient of stiffness, coefficient of flood, maximum flood for 100-year return period, maximum flood for 500-year return period. So the Gumbel method, log persons methods we have used. The basic formula means x var is equal to summation of x divided by n. Standard deviation is equal to s squared summation of x minus x bar power 2 divided by n minus 1, where coefficient variation cv is equal to cv sigma divided by x bar. Coefficient of strictness cs is equal to summation of x minus x bar whole power 3 divided by n minus 1 star into summation power 3. The return period t is equal to n plus 1 divided by m. M is equal to rank. The percent probability of frequency is equal to 1 divided by t into 100, where value of x with respect to t, xt is equal to x bar plus k into tau, k is equal to yt minus y bar into n divided by sn, yt is equal to reduced variate my into inch t divided by t minus 1, y bar into n is equal to reduced mean a function of n, sn is equal to reduced standard deviation a function of n, where flood frequency Gumbel method p is equal to 1 minus e into power minus e minus y, t is equal to 1 divided by 1 minus e power minus e minus y is nothing but reduced variant is equal to 1 divided by 0.78 into tau into star into x minus x bar plus 0.45 tau, where x equal to flood magnitude with the probability of occurrence p, the qt is equal q bar plus q tau into 0.78 into inch t minus 0.45 for n is greater than 50. The Gumbel method. So see the serial number, year, maximum flood occur in this area. So 27. Okay. So see 67 to 77 years we have occurred the flood values here. So the Gumbel method of estimating frequency of flood here, maximum flood rank based. So rank we are assigned 1, 2, 3. Then recurrence interval t is equal to n plus 1 divided by m. So n plus 1 divided by m, substitute for this value we got this number of values. Then percentage probability we have to take the probability p is equal to 1 divided by t into 100. Then x minus x bar we got this value, x minus bar the whole power 2, we square part this value we got this one, and square part this cube, sorry, power cube, this we got this value. Now maximum flood, then reduced variation y is equal to x minus x bar plus 0.45 star into 2 divided by 0.78 star into tau. So x plus minus y, then we got x plus into x minus x plus and minus y we got this value, then e power minus y we got this one. Then recurrence interval y r t is equal to 1 divided by 1 minus e power minus y we got this much. Then probability p is equal to 1 divided by t star into 100. So the mean, then recurrent period, then qt commerce, then probability p is equal to 100 by t into 100. So n standard deviation, coefficient of variable, coefficient of significance, we got this much of value. Then meanwhile we have to draw the graph, time comes based, the error if data is not available more than 50 years. So qt is equal q average plus standard into 0.78 into inch into t minus 0.45. So this return period t based research, then return period t based research, t versus tv versus q, then t versus q. So see here qt commerce, then power based, then qt commerce based. So log person types 3 distribution, the peak period based histogram for random numbers, then log Pearson type 3 distribution cs equal to n into summation of z minus z bar power cube divided by n minus 1 into n minus 2 into tau z power cube, or summation of z minus z bar into power 3 in divided by n minus 1 into tau z power 3. So z is equal log x, z is equal z power bar plus kz into tau z, x is equal to anti-log of zt, where from cs dash equal to cs into 1 plus 8.5 divided by n. So kz is read from table cs versus t. So this table C, the different return period T and CS, then KZ for different return period T and CS. So the a particular year, okay. So particular year we got this much of value. Likewise, we can estimate the frequency. Initially, we have to assign the rank in based on our use, based on our assigned years. So if last 20 years we are taken for analysis the frequency, na? So first year we are given the rank like 1. So likewise we have to calculate it. So the table will be continuous. Z is equal z bar plus k z into tau into z. So n mean qz q value you got, the standard deviation, coefficient of variation, substitute this value into formula, then we got simplified the values. So result, so z is equal to z bar plus kz into tau z. So 100, 200, 1000 we got variation from the normal values. So the descent flood estimation, standard project flood likely to occur. This is normally about 0.82 of MFV, and maximum probable flood. Okay, the maximum flood that can occur, spillway, descent flood, the actual flood estimate for designing any structures. The special project flood GOG factors A and B for standard project flood method area AB. The government of Gujarat QSP F is equal to 0.8 into A into C power B. Then we can substitute this value in square kilometers. So these are the reference material. Thank you.